each of these, okay, each of the RDDs must have a same number of elements. And all it does is take one element from each of the RDDs and pair them up. So as you can see, X and Y, each one has 3 elements. And once you do a zip, what you get back is a pair RDD. For each pair will be one value from each of the elements in the same order. Right, so you see 1, 1, 2, 4, and 3, 9. So the key thing is these two RDs must have the same number of elements. Otherwise, the zip will not work.
So can I think of this as a join?
No, because it's not joining by key at all. All is taking each element.
If one is a key, I mean, if the first element is a key, wouldn't it do the same thing?
If you think it as a join where the key would be the index of the elements, then yes.
Is this a paired RDD, the Z?
What's being returned to pair RDD, yes. Yeah, you can kind of think of it as a join, but join usually you have the same key with multiple values. In this case, you will always get a pair with a single key and a single value.
Yeah, okay, but a heavily restricted join.
Yes. Yes.
So what are some cases where you would use zip?
You have 2 data sets and you want to be able to manipulate them by first combining these elements together and then do some kind of processing on it. Maybe you have an X and Y coordinate in separate RDDs, for example, and then now you're able to have each pair at X and Y, and then now you can plot them, for example. So yeah, that's something I just thought of, yeah. Okay, so that wraps up for the transactions. And again, transactions are lazy evaluated. Nothing happens until you take one of the actions. That's when Spark will trigger the computation of all your logic from doing all the transformation up until that point when you take an action. Okay? And according to this, the action will, Spark behind the scene will take all your transformation and create a DAG out of it. Basically, that's a logical DAG, directive ASIC graph, and then transform to physical operations and then compute those in distributed manner across the cluster. All right, so non-partition, this is where you just find out how many partitions a particular RDE has. So this is more like getting metadata than anything. That's the only interesting part about it, but other than that is not that interesting compared to the actions. So in Scala, you can say dot partitions, dot size. That will give you the number of partitions a particular RDE has. Okay. So collect is something you use pretty, something that's used pretty commonly used. It basically returns all the elements in an RDD from all the partitions back to the driver, right? The driver in this case is your Spark shell. So the only thing you have to be careful about this is to make sure what you're collecting is small enough that can fit into the memory, the amount of memory that the driver has. So you definitely don't want to collect back a terabyte of data from your RDD. Usually you do some kind of filtering, and then you get down to a much smaller data sets, and that's when you collect back. So collect back, and that will bring back to the driver, and then you can do something interesting with that. Reduce is basically reducing the elements in the RDD to a single value. So in this example, we do reducing by doing addition. So we provide a function to reduce API. So you're going to see example here, reduce you got A and B, and then from that you can do addition, or we can do multiplications and whatnot. So in this case, 1, 2, 3, 4, we reduce it down to 10 by performing addition.
But,
that's pretty straightforward.
Yeah, so just to make sure I understand the process, it will first conduct the operations on
Each of the
partition
partitions,
and then bring together. So we can't. So this doesn't apply to anything we would want to do that would I forget what you called it, but things like sort where you need to have everything. Or I guess actually even that you could do by partition first and then all the way together. Yeah, okay. No, sorry, I'm on board.
Okay. All right. So the only thing to have to be careful is whatever you do in the reduce function, it has to be associative and commutative for this to work properly. Yeah. Okay. Aggregate is like a flexible version. Reduce is implemented by using aggregate, and aggregate is one of the most a little bit challenging to understand. But I'm just gonna give you a quick version, and then you can dig deeper afterward. But basically, aggregate takes an initial value. In this case, is the initial value is it's a first parameter. In this case, it's a pair of an empty list. Let's go to Scala. An empty list and a seed value. And then it takes two functions. One is they call it seg up and combined, basically. Let's take a look at the result first, and then we'll come back to what it does. On the output, let's say the input is 1, 2, 3, 4. Then when we do aggregate, what we will get back is a tuple that has two elements. The first element is an array of all the elements in the original list. And in the second output value, it's a 10, because when we do combining, we do addition effectively.
So is this basically this is what we would use if we want to specify the order of operations?
What do you mean by the order of operation?
It seemed like what you tell it is we want to operate. We're doing an addition here, but instead of doing 1,
you could do something else.
We're doing 3 plus 1 plus 2 plus 4.
Yeah. So when we look at a description, aggregate all elements of the RDD by applying a user function to combine elements with user-defined objects, then combine those user-defined results in a second user function. So it takes two functions. It's very confusing at first. So we walk through the example here. The seg-op, what it does is it takes a tuple of two elements. The first one is the list, the data, and there's an int after that, and then there's the third element. So
Sorry, go ahead.
So in the actual logic, it takes the list, which is the first element in a tuple, and it appends the item to the list. You see the colon plus, so it's appending that to the list. And what the second element, data._2, it does an addition. It's collecting into a list as well as adding as it goes along, right? That's what it's doing. And then combining takes D1 and D2, and each one, it's a tuple. And in the logic, what it does is it takes the first element of each of the D1 and D2 and then union them together. So these are using two lists together. It's a combining list, effectively. And then D1._D2 and D2._D2, basically that's the sum from the previous operation. So you sum them up again to get the 10. Is that confusing?
Yes.
Maybe
I
we
don't
go
know
back to the,
COM-Q look like.
let's go back to the initial here. So we have 4 partitions in this example, right? And then as we go for each one of these, what we do is we add 1 to the list, and then we do the sum. The sum start with 0 because we seed that with 0. So we get a list of 1 element with value 1, and then the sum so far is 1. That we, well, I'm going the wrong way. Now we go to the next part, which has 1 element of value 2, and then of course the sum is 2. And now we combine them together. So now we have a list of 2 elements, and then the sum of that. Finally, we go to 3 and 4, and then again we do similar thing. We add them to the list as well as doing the sum. And finally, we do the final aggregation, combining union of these 2 lists, also the sum of the second element. So now what you get is 1, 2, 3, 4, and 10.
1, 2, 3,
hopefully
4
that
is
makes
the initial, yeah.
Yeah. So hopefully that makes a little bit more sense. It's pretty powerful. You can do a lot of stuff. It just because it's a little bit powerful, therefore a little bit challenging to understand at first. But I'll let you play with that some more.
Okay.
The next one's max. Max is pretty simple and just understand. You give it a list of values and we're trying to do the max out of it. You don't have to write your own logic for doing a max. Obviously, this only work with int RDD or long RDD, numeric RDDs, of course. Sum, same thing. It's a sum set up for you. For doing a mean. So that might be useful when you're doing some kind of statistics. Standard deviation as well. And by the way, there's a method called stats, and it does all these things. Min, max, sum. Yeah, so it's pretty useful, right?
Yeah. So I know you sent me some reference code, but if I wanted to calculate the 75th percentile,
yeah.
So the way the link you had sent me was that you basically sort it and then, take the
75th position.
Yeah. The 75th position.
Yeah.
Yeah, I don't know. I was wondering if there was using some of the methods we've just covered, if there's something that seems a little more.
Yeah, I don't think it out of the box. It has a method for an API called say, hey, give me percentile, and you give it the value. I don't think it has that out of the box. But I think you can kind of write that based on the logic from the link that I sent you.
Yeah.
All right, count by key is pretty simple as well. So you have a bunch of key value pairs and you count by key. So it'll give you the key and how many times, how many elements that have the same key. So in this example, you got J, F, A, J, and then when you do count by key, you got A with 1, J with 2, and F with 1, for example. So that's ignoring the values, looking at the keys, how many times a particular key appears in the data sets. And what's being returning is a map of keys and a count. Okay. Save as text file is something you use, so you want to actually store your RDD out onto ECFS or onto a local file system in text format. And it has other ways of storing into other format as well, like Avril and Parquet and stuff like that.
So just to go back a little bit to so combining this with what we saw in that aggregate method or action, the plus item. So if I'm say I'm computing, I'm looping over 10 different items, 10 different RDDs, and for each one I'm calculating the mean. And I want the output to be just a list of the 10 means that I've calculated.
Uh-huh.
So can I do, basically I define an array, say that will be like data on here, and then every time I do plus item in order to append that result, and then I save data as text file.
Wait, back to what I think what you described is you have 10 RDDs.
No,
right?
Or yes, 10 RD, yeah.
So these are separate RDDs.
Mm-hmm.
And you said for each one of these, you calculate the mean.
Yeah.
Right? So, and now you have 10 values, one mean for each
Yeah.
of the RDDs. Right?
Yep.
So in that case, all you have to do is just RDD1.mean, RDD2.mean, and then that will give you back a single value, right? And then now you have all that in a driver.
But what I want to get is I want a CSV file with 10 rows that has
And what would be in each row?
the mean of RDD1, then the mean of RDD2, then the mean of RDD3.
Oh, okay. So that's pretty simple.
Mm-hmm.
So for each of the RDDs, you do a mean, and that will give you back the value for the mean of each of the RDDs. And then all you have to do is, now it's just like numeric values, right? You have 10 of these. You can put them into a list.
Right. And the way I do that is by using this like plus item construction.
It's simpler than that, because now you have on the driver side a list of 10 values, right?
Mm-hmm. How do I put each of these into a list? I know it's very simple. I just don't know how to do it.
Oh, okay. So you have to create something like this. So this is just straight Scala, by the way, from the logic that we talked about. So you're gonna have like a var full array. Oh, spell array. I can't type this morning. Oh, I should do int, for example. So now I do v1, whoop, what was it, plus, right? 2. So now I have an array of, oh, I need to assign that back. So it should be, well, right? So I'm appending to my array. So now I have what? 4 now, right?
Okay. That's really all I wanted. I just didn't.
Yeah. From there, and then you can just save it.
So v equals v colon plus
whatever the value that you want to add to it. Yeah. In your case, your v might be of the type of double or something, right?
Right. Or even, and I also, what if so this is just for a simple list, but what if I actually want an array of tuples, because I want the RDD name and the mean.
Oh yeah, so it's similar. You would do tuple so you would have string and double maybe, right? The name and the value.
Yeah. Wait, why did you write tuple 2? Oh, just because it's...
Yeah, tuple is kind of, if you know your tuple has 2 elements, then there's a class called tuple 2.
Specify.
If you know there's like 3 elements, you say tuple 3. Okay. And then you have to you have to tell it what the types that are going to be for each of the elements in the tuple. And then, then you can just add like what we just did. Colon plus, we say tuple of Friday and 1.5. Oh, I didn't do the assignment. Right?
Okay, so
You got
V1
it?
equals V1. Yeah, awesome. That's exactly what I need.
Okay. Yeah, so that's just Scala, basically. All right. We did mean, we did standard deviation. Yeah, there's nothing special there. We did count by key as well. Yeah.
Yes.
Yeah, we're almost done. Oh, we talked about save already. Save as a text file. Oh yeah, when you save, then you need to give it a directory. That directory must not exist. Okay? If it's already existed,
okay,
then it's going to fail. Okay?
Give directory that does not exist.
Yeah. Because if you accidentally override this, which could be a result of like running a 2 hours job and then you accidentally override it, that's not good, right? So that's why I always want to work in this mode where when you write out something, that directory must not exist.
And how would I remove a directory? Would I do it from inside Spark?
Yeah, I think that's utility. I think this case example have DB utils. I'm not sure where that's coming from, but there is a way for you to remove a directory before you write it out. Either that, or if you write out data for like per day partition, then you can append the day or the hour to the directory name.
Right, so, but at some point you want to clean up.
Yeah. So that is a way to clean it up. I think I have to find out what DB util thing is. So it looks like that's an example of how to remove a directory.
Maybe it's a package we can include at the beginning.
I need to find out what this thing is. That's what they're talking about. I haven't used this one before. It looks like it is available. Let's see. I don't know if it works, but let me try. Utils. Yeah, I think I need to import it because if I do this code completion, nothing comes up. Yeah, we need to import it from somewhere. Gotta find out. Yep, so I think that's pretty much it.
Okay.
I mean, there's other action that's not in here, but you can look them up. I'll do an account, take, and there's take order. Take order is interesting. I'm not sure you've seen that, but take order allows you to take the first.
Take, but not take order.
I'm sorry?
No, I was just saying that, yeah, I've seen take, but not take order.
Oh, yeah, take order allows you to take like the first 20, the top 20, for example. And by default is ascending order. And if you want reverse, then you have to do something different. And so let me give you an example. Let's say I do val RDD1, parallelize, and let's say array 1, 7, 8, 2, 8, 4, 6. So RDD1 dot take, let's say I want to take 5. As you see, it returns right. It returned the first element, but they're not in any particular kind of order at all, right?
Yeah.
Is this a sample, like random sample, or?
Yeah, it basically the first element from each of. You can think of it as like a random sample, if you will. But I do take order. You see the values that come back, right? Order.
Yeah.
So this is like a top 5 value in ascending order, right? Take order, that's what it does. And then if I want to take 5 in descending order, so that is an ordering object. And I say reverse, and it gives me the top 5 in descending order.
So it's gonna sort
So
before
if
that.
you have, yeah. So if you are, top 10 by click count, for example, that's just an example how you would do it.
Ordering.
Any comments or questions on take order? Take order is pretty useful.
Note down the function, yeah.
Okay. And then if you have a tuple, then I'm sorry?
This is really helpful for troubleshooting. So I want to note it down.
Yeah.
Yeah,
and if your RDD is in a tuple,
yeah, did we figure out how to
RDD
save the file? Oh, sorry.
Ken, go ahead if it's a tuple.
Then because your tuple could be 2 or 3 elements, right? So you have to tell it which field to do the sorting by. So you would have to do one more thing on, and then your tuple, and then which field. If you want to order by the second field, and that's what you have to do. If it's the first field, then do 1. Does that make sense?
Yeah, it's like a SQL.
Yeah. So, for example, if I have an RDD of tuple, and maybe it's a character and a count, Z, 5. And maybe one more. G, 7. Right, that's an array of tuples. And this one too many. Order. Yeah. Take order RDD2. I wonder what it does. What happened? Oh, what am I doing? Interesting. Ordering. Let's see if this works. It looks value. It's RDD2. Whoa. What happened to RDD2?
How can I see what the RDD2 look like?
To collect this. Looks like RDD2 is messed up. Okay, let's try this one more time. RDD3 equals generated. Oh, you know what? You guys know what happened?
There's one more parenthesis.
No, I made a very silly mistake. All I did was create an array.
Oh, didn't serialize it.
I didn't do parallelize it. That's
Oh, yeah,
why. That's why when I do like collect, which is RDD API, right? That's why I didn't see.
Oh.
So now if we do take, see now take order work, right? Order, and I say 5, and it's probably gonna say whatever. But now I say take order, and I say ordering int reverse on which element do I want to sort by? The second, right? So now that's what you get: 7, 5, 3, and 1. Okay.
Great.
Yep. Any other things you want to cover?
Jess, do we know how to save as text file? I wasn't quite follow, but basically, if we have this file, we want to save it into each row, a different data point. Is that the text as save as text file function?
Yeah. If you have an array of, let me do that. I think already is it 1? Yeah. So if I say rdd1 dot save text file temp, and let's say where's it Friday? Okay. And if I go to my temp Friday, wow, that's a bunch of parts. Again, notice it gives me like 7 part files. And if I go rdd1 dot partition length, there's
Are
8
you on
partitions.
Or this is different cluster?
No, this is running everything locally.
Oh,
so
okay.
you see there's like 8 part files, right? Because each partition will be written out as a single file. Obviously, that might not be ideal because.
Collect before you.
I'm sorry?
So you need to collect before you save as text file?
Well,
if you want it all to be on one
collect will only give me back to the driver though, right? So if I want to write this out to a single file rather than 8 files,
yes,
what I can do is coalesce.
Coalesce.
Oh, coalesce.
1. And then now I can do save as text file.
Oh, you collapse it into one partition and then save.
Yeah, because your data set is small enough that can be, Now, so like I mentioned before, you can't use a directory that's already existed, right? So that you get this problem. It will say files already exist. So that's why you're going to have to say Friday 2, for example. And voila, and then I go over here. Then I say Friday 2. Then I only have 1 file. You see that? If I do a more on it.
We cannot specify the file name, looks like. It's always
can't. Always a directory. And look at that. 1 element in my RDD is per line. Because that's how text files works. 1 element per line.
Cool.
So if we wanted it comma separated, so like say we want to save an array of tuples into a comma separated format.
In a single line or what?
Yeah, so say I had, back to my example where I have, like, I want RDD1, I want an array of tuples where the first element of the tuple is a string, that's the name of the RDD, and the second element is a double, that's the mean.
Yeah. And each tuple exists on its own line?
Yeah, I want each tuple on a line separated by a comma.
Oh, yeah. So we would have. Like, for example, like this, right? So if rd3 dot save as text file, Friday 3. Oh, we should do coalesce before, otherwise we write them. So if we do that and see what happens. So Friday 3. Voila.
So it does it automatically.
Yeah, that's how, when you print out a tuple, by default, that's how it formats it. Parenthesis, element 1, comma, element, value 1, comma, the value 2, and things like that. That's the default formatting of a tuple. Because that's what it looks like when you do on the console, when you do collect. Right? You see parenthesis, value, comma, value. So that should work for you. Anything else?
How do we remove the file? Do you know?
I need to find out where does this db utils. So let me get back to you on that one.
Okay. That's all.
Yeah, thank you so much, Him. Yeah, this I recorded. This is very helpful. We're probably gonna need to play to follow the command.
Sure, yeah.
Jesse, do you have more follow-up questions?
Not at the moment. Yeah.
Yeah, we're probably gonna take time to digest this a little bit, Him, and just when we have questions, might get back to you as well.
Awesome.
Yeah,
have fun.
This has been really helpful.
I'm glad.
Yeah, thank you so much. I will share this with the EGC team as well. But this is really helpful at this stage. We're stuck in the the technical challenge here. Yeah.
Got it. All right, have fun with Spark.
Thank you.
And happy Friday.
Happy Friday.
Bye.
Bye.
Natalie?
Yes.
Do you want to talk quickly about schedule? So right before Hyun came on, I think I can meet. If there's someone who can help with optimizing the pig script, I can probably do today after 3 Pacific time, 3 your time.
It's 3 my time.
Yeah.
Yeah. Let me just quickly check the schedule for that
next
person.
Week. Yeah.
3. Yeah. I think. What about 3:30 till 4 my time?
Yeah, that's great. Yeah, I think I can do that.
Okay, let me just send an invite to see if that person replied. So I'll send it to 3 to 3:30, right? That's what I said. Oh, hold on.
You said 3:30 to 4.
3:30.
Either way is fine with me.
Yeah, let's do 3:30 till 4. I'm sending out an invite, so I have to run, but okay. 3:30 till 4. Okay, ETC help. Okay. Thank you. Yeah, I will. I'll send out the invite and see.
Okay. Well, I'll talk to you later then. Bye.
Yeah, talk to you later. Equal. One. Yeah, whatever. Mm. Hey.